So here's what I built in this video. It's a little voltage and amperage meter that has banana plugs on the front, so you can just plug universal power things into it, and you can read the amperage that goes through the side part, or actually a small amperage can go through the negative through here. Like I'll power this little bulb. The battery's right now is at 12.1 volts, and the bulb is pulling 1.86 amps, and the battery drops down to 11.7 volts while I do that. And this whole entire unit only pulls about 10 milliamps of current, so it's an extremely small power footprint. So I could just leave this permanently plugged into my battery, so I could always come and check on them to see what voltages they are. But let's see how I build it in this video. So today we're building a little universal voltage amperage meter that I can keep on like a battery or something if I want to keep an eye on it. We're going to be putting it inside of this project enclosure that I got from Radio Shack. And I'm going to be using this dual LED voltage amperage meter that I got off of eBay. It's extremely non-precise. It's kind of a couple digits off, but it was only 14 bucks. Now for the voltage, I'm going to be having two wires with alligator clips coming out of the box. These two wires will be the power input to power the meter, and also the voltage detection. So it'll detect the voltage that it's running off of, and it only pulls a couple milliamps of current. That's the milliamps. If we bring the voltage up, milliamps go down a little bit, I think. Well, anyway. And then for the amperage reading, because we can't have if we're going to be pulling or measuring amps, we can't let it go through this little circuit and burn it up. So we have to have the amperage going through this shunt. And now what I'll do is, so I can connect wires to this shunt, is I'll just have the bolts going through the side. I'll have it mounted on the inside of the box, and have the bolts coming out the side, so then I can hook alligator clips to it, so I can measure how much power is going through the system. Now what's really nice about these project boxes is that they come with a plastic lid, but you can also just use a aluminum lid. And I believe these cases are made of ABS plastic. That's basically the same type of plastic that's in that like Game Boys and stuff are made of. Pretty much everything. It's a good plastic. Now the great thing about these little meters is that they have little clips. So basically all you have to do is cut a square out, and then that's the right size, and you can press this into there, and the clips will hold it in place. This unit itself is about, I'd say, 1 inch tall and 1 3/4 inches long, or wide. Now you might be able to see that I scratched out where I want the meter to go. So let's take it outside and use the Dremel to cut that little square out. Well, that looks pretty nicely. It's really nice and flush. Looks a lot better than a lot of the other things I've built. So now we have to hook the current shunt onto the inside of the box, which entails us drilling holes in the side of the box for the bolts to go through. And I don't have my drill press with me, so I'll do it pretty much the exact same way I've always cut through these. I just drill a hole with my pocket knife, and then I make the hole bigger by turning the end of a file into it, and that just spreads the plastic out. So now we have the holes drilled. Let's add the shunt. Now we gotta hook the wires to it, and that should be good to go. Now instead of having cables just running out with alligator clips, I decided I'm gonna try to use these banana plug thingamajigs. I think that's what they're called. Basically, they have two ways to hook up. They have a little hole inside of there we can tighten it down onto. Like for instance, you can put a wire through that hole and then you can tighten it down onto that wire to clamp it. Or you can put a plug into the end, like for instance the plug on my universal power supply. So I could use the little alligator clips for my universal power supply. So I think I'm going to put these like right here on the plastic plate. Just got to drill some holes for it real quick. And that would turn out perfectly. I can even connect my power supply plugs into it. So there we have the little unit. It's pretty awesome. Unfortunately, it's very lopsided, so it wants to rotate to like that because there's a big chunk of metal over here. I might glue another chunk of metal over here just to counterweight it. But once I did, it would have a nice little weight to it. Inside, it's quite simple. These two are connected. So this is positive and this is negative, and this is negative, and this is the amperage draw. So power, I could power this just with positive or negative and pull power from it, but that would be pulling power through this wire right here. So if I was planning on pulling a lot of amps from it, like more than 2 or 3 amps, then I would put a jumper cable, a big one, from the battery to, or whatever I'm measuring, to this plug, so it wouldn't be having the negative power going through here. And now let's put it, and just screw it together and test it out. Well, I just remembered that I had an extra pair of jumper things from my IMAX P6 battery charger. It had the same little connectors, so I'll leave these for that, since I hardly ever use that thing. And the voltage is pretty close, only about 0.1 of a volt off, and it has a little knob on the back. I could adjust that. And the amps are 0.4 of an amp above too much, but that's as low as the adjustment will go. But it was the cheapest meter on the market, so oh well. I can whenever I'm testing amps with it, I can always know to subtract 0.4 amps from whatever I'm measuring. Now it's time to make sure that it measures the amperage draw. So I have this little fan hooked up, and I'll just touch it to this and see if the number on here matches the number on there. It's about 10 times the number. Oh well. Oh, that's odd. I didn't think it would detect anything down there. Oh well, the voltage works, so all I really wanted was the voltage anyway. Oh, I remember now. The this crappy little model, it switches from measuring milliamps to measuring amps, but it doesn't change the decimal point. The little decimal point is just hardwired to always be on. I forgot that really threw me for a loop for a long time until I realized that. So that is measuring it, but that's measuring 140 milliamps, not 1.4 milliamps. Oh well. So let's test it out. We got our really sulfated deep cycle battery. We got our little old bulb, which I think takes about 1.2 amps. Don't know for sure though. Let's find out with this thing. Voltages are reading 12.1 volts, and let's hook up the bulb and see how many amps we're pulling. 1.8 amps. That sounds about right. Remember, the decimal point's all messed up. So that's pretty cool. And this is probably where it'll stay mostly, is just on my shed battery pack. So I can see how well my solar panels are charging my battery system, and when I charge it. And And with this meter configuration, it's measuring the voltage of all the other batteries, and then it's measuring how many milliamps of current is going into this battery to keep its voltage up. Because I'm using the other batteries to artificially bring up the voltage on this battery while it desulfates until it can hold the voltage on its own. Because otherwise, if I just let the voltage go down, it would be kind of like erasing the data of all the progress I've already done with it, of desulfating it. And so right now we can see that with the other batteries at 12.6 volts, 340 milliamps of current is going into this battery to keep it up. So that means I have probably like 20 hours before I'll have to recharge those batteries. And then after a couple weeks, whenever this is desulfated, I won't have to do that anymore. And I can use this for just measuring the entire pack. Well, I hope you find this project to be useful somehow, and I hope you enjoyed the video. Thanks for watching. Bye!